Hi, everybody, and welcome to this live session for Astronomy 120. Today is Wednesday, February 15th, and this is for the late class, for the late start class. We're meeting in this class for the first time, and we will be probably meeting down the road also. Not on a regular schedule, since this is an online class. It's going to be an async course, meaning that basically I will record stuff. There are things that have been recorded already, and it's going to be posted. You're supposed to do your work online, and we're supposed to communicate online. That's the whole idea of it. Some of you actually are sitting in my Astronomy 125 class. Again, the late start, that starts tomorrow. That is actually the lab version of Astronomy 120. And you're not required to do that. I mean, it's actually a good class to have if you can, if you have time. If not, it's not required, namely Astronomy 125. But Astronomy 120, since you are enrolled in it, this is the course that, hold on. This is the course that we are basically talking about, namely Astronomy 120. Again, as I was saying, we are not meeting on a regular basis. We will have meetings from once in a while, and especially in approaching exams, so that you guys can see what's going on and things like that. We will have three main exams in this class, midterms, basically. And, or is it, let me make sure that I have the number correct, okay? Please consult the syllabus, because we're going to follow the syllabus to the dot. Everything is on Canvas, so you must have access to Canvas by the time you're watching this one. For those who are not alive, you must have also, not alive, I'm sorry, not live with us on this session. You must have had access to Canvas, because those are the how you're going to access it, basically, because I'm going to post a link to Canvas. The way it works in here is that a lot of content is on my YouTube channel, and if the way to find it is just put my first name, DJ Bouzidi, and you will be able to find it on YouTube. What is relevant for you should have in the title of it should have the stuff that is relevant for your class. So if in case I want to post something for Astronomy 120, I put Astronomy 120, and it's going to be there. There's already a lot of content in there, so you might sift through it to see what is important for you. However, you don't really honestly need that, because I link back to all of that content on Canvas. Granted that if you have access to the YouTube, you will get the materials firsthand, because once they're uploaded to the YouTube and YouTube makes them available, they will be available to you. Whereas it will take me time to go and basically find that they have been successfully posted, and then actually go and provide the link for you guys in Canvas. So that may take a little bit of delay compared to the fact that you have these things right away on Canvas, on YouTube. So this is the idea behind the how this course is laid out. There was already a question, and I'm glad that one of you guys have asked that question, and that is how the discussions work, okay? We have already an assignment for the discussion for the main one, the entry one, the one for has to do with the flat Earth. You're supposed to go Google or check on YouTube or whatever resources what people are arguing for, what are the reasons we think the Earth is flat. And of course, you're going to listen to those reasons if in case it's in some sort of a media format like on YouTube, or excuse me, or read through it if it's on Wikipedia, not Wikipedia, it cannot be, on any blog or something that somebody's posting out there. And you're supposed to bring the rationale and arguments and provide the link for that. Don't forget to introduce yourself. So that's basically how it is. And there is a link for that. There is a due date for all of my assignments, so make sure you observe those due dates. And also, you post a couple of replies to your peers. So this is the main discussion. Other than that, you will be having prompts every week for weekly discussions. I would say the vast majority of them, except toward the end when we have exams and things like that, they are graded, okay? So you must adhere to those discussions. You must go and look at the prompt, okay? For example, the first week, you're supposed to compare the right ascension and the declination versus the latitude and longitude that are used by to locate objects on the surface of the Earth versus how to locate objects in the sky. You take the Earth and you project it in the sky, and you will have what is the celestial sphere. The equator of the Earth becomes the celestial equator. The prime meridian that passed by the city of Greenwich in England becomes another corresponding origin, which corresponds to March 21st of the year 1900, for where we start measuring the angles, except in that case, the angle is measured in not in degrees, but rather in hours. So the right ascension and declinations. This is not the purpose of the lecture, honestly. I'm hoping that you guys can go through the materials in the book, and then also go through the discussions that I have already, the videos that I have already uploaded for you guys, and you should be able to find an understanding of what those things mean. If things are not clear, if the book does not meet your basically detailed explanation expectations, or the videos are not, please reach out to me. Ask the questions so that we can have these clarifications. So again, this discussion, you're supposed to go and talk about the comparison between how to locate objects on the surface of the Earth and how to locate objects on the celestial sphere in the sky, basically, when you go outside tonight, for example, and you're curious, trying to find where the Orion constellation is. Where is Betelgeuse? Where is Bellatrix? Where is Rigel? Where are all of the stars? Aldebaran, for example, a series. So you would want to find those stars. Of course, you need to locate them. Here is one, here is another one, here's another one. But there is a scientific way of representing them, and that is the declination and the right ascension. Or in the case of something on Earth, for example, where in the world is Chicago, for example, in terms of geolocations, and you go Google, for example, Chicago downtown on geolocation is going to give you specifically its latitude from the north of the equator and its longitude west of the prime meridian, and it will tell you exactly where Chicago is supposed to be. Okay, or whatever city you are interested in. Okay, Lima, for example, in Peru, or whatever you're trying to look for. So the point being in here is we locate objects on the surface of the Earth, and we locate objects on the celestial sphere using similar but distinct or different units, different names, and different conventions. Okay, so that's the discussion of this week. So you're supposed to read, understand these things, and come and present your feedback, and then look at what your peers are talking about in here, and you may have to interact with them. Okay, so this is basically the question that was sent by one of you guys earlier today about the discussions. Okay, other than discussions, you will have actually homework assignments. And if you noted, there is on the YouTube channel, there is already some questions from a previous class that started, the full-term class that started already, about homework number 1. So I made that video available for that class, but again, for you guys, it's going to be available. All you have to do is just go to YouTube and find how to homework 1 deals with a bunch of questions, one of them in how to predict, if you wish, the next solar eclipse. Okay, that's actually the homework problem. You're given a setting, you're given a specific solar eclipse that will happen in 2027, and you're supposed to make a prediction when the next solar eclipse, based on a specific model, is going to be, and where it's going to be, not just when and where. So you're going to, based on that homework assignment, you should be able to predict the location of the next solar eclipse, and also when it's going to happen. Okay, so that you can plan and basically go to that place. I mean, it's no secret, it's going to happen in here in North America. Anyway, the point being in here is that resource is available for you already from the previous class that one of the students have asked. But let's say, for example, that class did not ask a specific question that interests you related to that homework. So in this case, you ask, okay, how am I going to do it? No big deal. We can sit down and work it out, and then I will share the resource for your class. So homework assignments is actually essential, and it's a very integral part of this class. So you make sure you do that and do it on a regular basis. And there was another question actually from another section about the time that I need to allocate for this class. Between the reading the units, remember, sometimes you only have one unit to read, and the units are kind of small, like less than a dozen pages, okay? It's not a whole chapter book. It's not like another, so that's why I like this book, because it takes the entire content and breaks it down into units, doesn't even call them chapters, because they're small, okay? So you read the unit, which is sometimes one unit, sometimes 3 units, depending on the content and content for that week and how it's related. You read those units. If there is some side notes or practice sections, you're going to do that. And then you come to the videos and you watch those videos. Those videos are about an hour each, okay? So they are long videos. You need to pause the videos, because you really have to be sitting throughout things, and they're done in an interactive manner, meaning actually students are there, so it should be easy enough to follow, okay? Then you do that, and then you answer the assignments, and you should be able to have been done with that week content. Between the 2 videos, between the reading, between the assignments, it takes anywhere between 6 to 8 hours of coursework, okay, per week. So that is the amount of time you really have to spend on this class, and it's a full load class. This is not a like a 1 credit class or something like that. So it's really a semester course. So the mere fact that it's going to be async online doesn't mean that we're going to wait until the final or the midterm to decide, oh, okay, I'm going to open the book and see what's going on. That is way too late. It's a weekly content that you're going to do weekly. Every week there is a discussion assignment. Every week there are stuff that needs to be done. So you really have to plan your schedule along this side and work your way throughout the entire semester that way. You'll be given exam reviews before the exam. The exam review itself is an assignment. In other words, you'll be graded for it. The grades you will get for the review are either 0% if you don't do it at all, or 100% if you do any parts of it. Even if you score, let's say, for example, 2 out of 300 questions or whatever that is. So it's still, you get a full credit, just to make sure that you're doing your due diligence to prepare for the actual exam, because it's an assignment by itself. You're supposed to do a review, and that should help you prepare for the actual exam, which happen later. So this is basically part of how the process works. The grades are divided into different sections. I mean, this is part of what is known as a participation grade, along with the discussions. And then you have the other sections for the homework, and you have the other section for the midterms, which brings me to another section of great importance, and namely the projects. You have 2 projects in this class, okay? One of the projects is going to start soon, so you're going to be receiving notifications for it. And the first project that you're going to be working on is for the lunar observations. For 4 weeks, one night of the 4 weeks, you're going to go out and observe the moon for 4 weeks. So it's not like something that can be done to the last minute. No, it has to be, you have to divide your time, and I'm going to give you the dates and when to go and observe the moon. So you're going to go out, look for the moon. Okay, here is the moon. I can see it. For example, this is what I'm facing, south west, southeast. I'm sorry, I'm pointing to southeast in my place. And it's midway between the horizon and my zenith. This is called zenith, which is immediately above my head. So it's midway, or it's closer to the horizon, or it's closer to the zenith. and it's southeast, as I was saying. That's the location. Then the shape. How does it look to you? Well, half of the moon is lit, and the other one looks like it's shadowed. Okay. And then I open the book, go to chapter 8, unit 8, I'm sorry, whatever unit that deals with that, and you're going to name the face. Is that a quarter moon? Okay. Is this the first quarter or is it the third quarter? I have to be specific. Okay. In other words, is the light that is lit, the part that is lit, is it facing west or is it facing east? In other words, is the moon following the sun or the sun is following the moon? So we should be able to see that one, because if the sun is coming from the east and the moon is still in the sky, then the lit part is going to be pointing toward the east, and the other one should be dark, and vice versa. Okay, so we should be able to tell exactly what kind of shape it is. Is it mostly bright and very little darkness on the moon? Okay, that's a gibbous. Is this gibbous increasing? Waxing, that's the word that is used in the book. Or is it shrinking? The word used in the book is waning. Is it a crescent? Meaning, mainly it's dark with the exception of a narrow region that is lit. And is this crescent waxing or waning? Okay, is it a full moon? Maybe the whole thing is just bright, okay? Or is it not there at all? I looked for it, you told me to go at night. I went looked for it all night and the sky was clear and there was no moon. And then I looked at it for it in the morning. I woke up very early in the morning, I looked for it, I didn't see the moon. So is this a new moon? Obviously, there are times, like what happened earlier in the month, when the weather is inclement. Basically, the weather is kind of there is clouds. So in that case, I can't see the moon. What should I do? Part of the plan is for this project, you go the night before to plan your observation. So your planning becomes your observations. Or if in case it was cloudy the night before and it was cloudy on the night of the observations, then there is a third chance to go to for the third night on the row. And from experience here in Southern California, it rarely cloudies for a whole half week like that one. But if it does, that's all you need to report. Okay, all you're going to need to say. So this is project one. You're going to be receiving reminders. At the end of the project, you're going to submit a report on it. That includes your sketches, that includes also your observations, and that includes all of the times you went outside and did all of these things. And I hope that you own this project because it's actually you're the one who did it, not some astronomer somewhere else that collected the data and gave it to you. Here it is. It's yours. Okay. So this is a project that I'm hoping that you guys will take care of. And then the other project is you'll be given data. So this one is going to be a little bit kind of concise, and I'm going to post something on YouTube on how to do because it requires a little bit of geometry a little bit. So here is the idea. The Earth, we know today, the Earth goes around the sun, okay? And it takes a year to go once around the sun, 12 months to go around the sun. Mars goes around the sun, but it's a little further away. So it takes longer time to go around the sun, okay? But they're not in sync, meaning it's not exactly 1 year for 2 years. It's actually 22 months and some change for the Jupiter, for Mars to go around the sun, whereas the Earth does 12 months exactly. So after 12 months, in 12 months, the Earth would have done 2 years, and it's back to where it started from. But Mars, the first time was here, and the second time when the Earth comes back to where it started, Mars was lag behind. because it did not do exactly 24 months. It needs another 2 months to do the 24 months of the Earth. Okay, so 1 year on Mars is actually 22 months in Earth, so the Earth has to do twice to catch up with Mars in the same location. Not exactly, moves back. Based on these observations, based on the data I'm going to provide you, you should be able to map the position of Mars over a long period of time. And when you do that, you're going to discover an amazing thing, that the path of Mars is actually an ellipse, not a circle. And you're going to measure how compressed the ellipse is. You know, ellipse is a shape that is known in geometry that has two focal points and an object goes around. That's actually the first law of Kepler that you're going to be learning. So this is one of the things. So you're going to discover that Mars obeys the first law of Kepler. Only that, but you're going to measure how elliptic path of Mars is. You're going to compare it to the known value, and you will be amazed with how accurate your data is, your observations are. It's going to be very close from the correct answer, which is, again, a skill that I'm hoping that you will take from here, because without anything else, that's what the old astronomers, that's actually what, what's his name? Kepler did actually too. He relied on the observation of Tycho Brahe, took that, and did exactly what you're going to be doing. So you're going to be a Kepler for a moment. You're going to do all of these things and decide that the sun is the center of the solar system, and indeed the path of the planets is an ellipse, according to the first law of Kepler. Because he was convinced after he did so many measurements like this ones, that the planets are going not on circles, but rather they are going on elliptical paths. Okay? So again, that's the second project. So this is part of the assignments that we have for this class, in addition to the midterms, and in addition to the participation grades, and in addition to quizzes, is projects. Okay, nothing is going to be without bumps down the road. That's expected. So if you have any difficulty, please let me know. I will do my best trying to post as much help as I can on Canvas, and also make recordings and post them for you guys. But you have to promise, you have to be fully engaged so that you do your part, because if you are sitting and doing nothing, this is not going to happen. It has to have your full, basically, engagement in the course. And the main thing I hope that you achieve with you guys is that you enjoy what you're doing, because if you're not, this is the most satisfaction you can get from this class is to enjoy it. Okay, so these are some of the things. In terms of the concept that we're going to be covering in this class, of course, it's astronomy. And I'm going to tell you a secret in here. Okay, this course, I know it has the name astronomy in it, and that's what a lot of people call it, and that's how it's called everywhere. But everybody, at least their instructors and people who do the thing, they know it's not exactly astronomy. It's astrophysics. So we're going to be learning about the laws that govern these things, okay? Because without them, we're not going to be able to understand anything. So we're going to learn about the objects in the sky for sure. We're going to learn about planets, and mentioned already Mars as an example. We're going to learn about Jupiter. We're going to learn about Saturn, Uranus, Neptune, Venus. We're going to learn about Mercury. Those are the planets. We're going to even learn about dwarf planets like Pluto, Eris, Makemake, Ceres, which is nearby, which is just in the asteroid belt, and Sedna, Haumea, and all kinds of other dwarf planets. We're going to learn about the moons in the solar system, like Ganymede, the biggest moon in the solar system, which is even bigger than Mercury planet. And then we're going to learn about the Titan, which is actually a big moon of Saturn, which is only second to to Ganymede, and it's actually bigger than Mercury planet. So those are two big moons. We were going to learn about Callisto, which is the third largest moon in the solar system, and it's about the size of Mercury. And then we're going to learn about Io, the moon of Jupiter, which is the third largest moon of Jupiter and the fourth largest moon in the solar system. And it's not too far actually from Jupiter, from Mercury, actually slightly less than Mercury, but it's a big moon. And that all of these four moons are bigger than the Earth's moon. We're going to learn about the Earth's moon too, a lot actually. It's going to help us understand objects similar to it, like Mercury, for example. So these are the objects that we're going to be exploring in the solar system. Then we're going to learn about the asteroid belt. We're going to learn about the Kuiper belt. We're going to learn about the Oort cloud. This is the solar system. Then we're going to direct our attention to the sun and try to explore the sun itself and what's going on in the sun, the structure of the sun, the outer shell. Then we're going to learn about the radiation zone, and we're going to learn about the convection zone before that, and the radiation zone, and then the core of the sun, where everything is happening in terms of nuclear reactions that powers the sun and help us understand things. So this is near home. And that is going to be the stepping stone to other planets, to other stars. And it turns out the stars, they come in different shapes and different forms. The sun is just an example, average star in terms of size and in terms of age and in terms of luminosity and in terms of all kinds of mass also, and in terms of luminance, how much brightness it produces, then how much energy it produces really per time. And then we're going to learn about some tiny stars, some failed stars, and some stars that are smaller, like Proxima Centauri, our next door neighbor, and then some supergiant stars like Betelgeuse. We're going to look at constellations. We're going to look at three types of constellation, the only three types of constellation: the circumpolar constellations, the one that go around the Polaris, the northern star. And then we're going to learn about the seasonal constellation that you can see them winter or summer depending on the time. And then we're going to learn about the zodiacal constellations, or the signs of the zodiac. So those are how stars are grouped in the sky. We're going to learn all kinds of things about these objects. We're going to learn not just that there are stars in the sky. There are some fuzzy structures also called the Messier objects. It turns out that they can be either globular clusters of stars, or they could be clouds where stars are being basically formed, nurseries for stars, or they could be their own galaxies, like our own galaxy, the Milky Way. And then that's not the only stars that you can see. You could have dead stars, like, for example, white dwarfs, like what the sun is going to end up being, or a neutron star, like a big star when it explodes, or actually a black hole. Then the galaxy itself is a huge structure of all of these things put together, including all the visible stars and the stars that we can see that emit light in the infrared, or even dark matter that is not even something that we can see or we can interact with. This is a huge structure. Inside of it, there is usually a supermassive black hole where everything going around. Galaxies have structure. Like, for example, our Milky Way has arms, and this sun happened to be in one of those small arms. And then it has also, our galaxy has a bar. It's a barred star. So this is our galaxy, and it's an elliptical star. I'm sorry, yeah, it's an elliptical star because it's of this structure. Sorry, it's a spiral galaxy because of this structure. The Milky Way is spiral galaxy, and we'll see other spiral galaxies, like, for example, Andromeda. And then we have elliptical galaxies, like, for example, when the two galaxies mix, they could form elliptical galaxy. So our galaxy is a spiral barred galaxy. And then we're going to learn about irregular shaped galaxies when they are going through their collisions. Galaxies do something, they eat each other, they are guilty of cannibalism. And after that, we're going to ask questions of the history of the universe. Where did this universe start from? And then, more importantly, where the universe is going to be, the fate of the universe. We're going to study all of these things using our own, basically, what we have, what we start with. And then before we end, we're going to talk also about life outside of the Earth, extraterrestrial life, basically, whether in the solar system or even outside of the solar system. So all of this requires tools that astronomers use. The biggest tools are, of course, we used telescopes in the past. Now telescopes are not really meant. They're actually computer being monitored by computers. So nowadays, astronomers, they just basically collect the data that the computers generate and give them that. We use also different techniques, light, and how to analyze light. And that's important because spectroscopy is a very important tool. Collect light from a star, take that light, you break it down into different frequencies, and from there you're going to determine the structure, the temperature, how far it is, and so on and so forth of the star. So because we're going to be talking about these things, we need to understand how we came to that. How do we know these things? Again, you have to always question things. You have to always wonder, okay, you're telling me something in here. How did you know that? You always have to have that inquisitive mind with you, always asking why. And the only way to answer that part is, again, by going back to the foundations, and this coming from physics, to understand what's going on in there, whether Kepler's laws, whether in this case using the spectroscopy to understand what's going on, and so on and so forth. This course is everything. I mean, if you know this course, you're going to know everything about everything, okay? And that's the plan. Hopefully, by the end of the course, we have a good idea of what's going on. Sounds exciting? Yes, maybe. Well, if it's not, I hope that you get excited as I am. And do you guys have any questions in here?
No.
No? Okay, that's basically all I had in mind, is just to make sure that we have at least the first contact, so that you guys have an understanding what to expect from this course and how this course works. If you guys don't have any questions now, we're going to end this session. But if a question comes up down the road, very important that you ask it, okay? Please don't underestimate any kind of something that bothers you or something that comes up to your mind. No matter how small the question is, no matter how it may sound to you that it's relevant, please ask it, okay? Because it may turn out to be something very important. And furthermore, those small things, if they're not asked during their time, they will pile up, they will grow, and they become a major problem down the road. So we don't want that. Okay, so we want to make sure we want to have a smooth sailing. Okay, we want to have no issues whatsoever, and for that, I would rely on you guys coming forward to ask these questions. Okay, where do we meet? Again, for the online version here, we're not going to be meeting on a regular basis. I'm going to be posting, in case we have to meet, I'm going to do the same thing like this one. It's not required to be live, but you're going to be getting the recording on as I'm going to post later on. Okay. But for the office hours, my office is in office 195 in the physical science building. So when you come into the physical science building from the parking lot number 4, you're coming straight through, you're going to be finding the main entrance, which takes you to the main building, which is a tall building. I mean, the straight building, okay? And that's actually taller because it has three floors versus the other one that has only 2, okay? So the side of which is attached to it is the new, basically, extension that they built a long time ago, but now it's actually a part of it. So that is where my office is in the same physical building, but the new section of it, which is 195. So when you go into the main building and start looking, it will tell you that the offices 190 something are on the other side. So you go there, you pass, if you're coming from that entrance, you're going to pass from 199, and you go through the hallway and you make a right. There is another hallway, you will find room 194. The reason why I'm saying that, because it's not easy to find it, okay? Because it's inside another room. So when you go inside 194, you're going to find two offices, 195 and 196. I am in 195. If you're coming to the office, please let me know ahead of time so that I am there for you. And if you just coming quickly and see if you have a quick question and I'm there, I'll be more than happy to answer it. But don't count on me being there all the time because of the fact that I have to be in class teaching labs or teaching lecture. Actually, I have some lectures on campus too. And also I may be somewhere else or that section, probably I have a meeting or something. The other place that you can find me in is on Thursday between 1 and 2 p.m. I have an office hour in person dedicated in the STEM Center. And that's room 145. The way to get to that room is, again, when you're coming from lot number 4, straight to the physical science building, and you go through the main entrance now, you go straight, don't turn left or right, or straight in, you're going to find the STEM Center. Once you are in the STEM Center, I'm in the corner all the way to the other side, basically near the sun, where office 145 is. And that is actually Thursdays from 1 to 2 p.m. I am there, okay? If both of these options are not good for you, there is the online. Just shoot me a message saying that you would want to meet, and I will be more than happy to meet with you. We'll find an arrangement that works for both of us. I know I have posted office hours, but those may not work for you. And if they don't, then we can always meet in any other time, including weekends. So if you want to meet, for example, on Saturday or on a Sunday, and there is an arrangement for it, I'll be more than happy to do that. We'll answer all of your questions, and if there's something that is, for example, of importance to the rest of the class, I will either going to record it later on, or I will ask your permission to record it, in which case I will basically, we will hide all of your personal information so that we record it just for the sake of the rest of the class, because it's going to be posted on YouTube first, and then after that, it's going to go to the class. The link is going to go to the class on Canvas. Okay. I know you guys said there are no questions, so I'm going to end the recording, and I will see you guys at least online on Canvas. For those who are sitting in Astronomy 125, which is the lab version of this class, I will see you tomorrow. Sounds good?
Bye.
Thank you. Bye.